The M shell is even further from the nucleus than the L shell. It has a 3s orbital, a 3p orbital, and a 3d orbital. The 3s orbital holds 2 electrons which orbit spherically. The 3p orbital is dumbbell-shaped and holds 6 electrons which are grouped in pairs. The 3d orbital holds 10 electrons, and there are many shapes for this orbital.
The second orbital is the 2s orbital, and it also has 2 electrons which orbit in the nucleus in the shape of a sphere. The third orbital is the 2p orbital, and it holds 6 electrons. The 2s and the 2p orbitals are located in the L shell, which is further from the nucleus than the K shell. The p orbital has a dumbbell shape. The 6 electrons orbit in pairs on 3 axes, the x, the y, and the z.
The 3d orbital is actually skit when electrons are added to the atom because the attraction to the positive charged protons is not great as the proportion of the negative charged electrons.
The next electron to be added to the atom after the 4s orbital is filled, moves to the 4s due to the electron repulsion. Element 19, potassium, has 1 electron in the 4s orbital. Element 20, calcium, has 2 electrons in the 4s orbital.
When another electron is added to the orbitals, the 3d orbital begins to fill up. The 3d orbital can hold 10 electrons. S stands for sharp, P stands for principal, D stands for diffuse, F stands for faint. S orbitals can hold 2 electrons, P orbitals hold 6 electrons, D orbitals hold 10, and F orbitals hold 14.
Radiation comes from the breakdown of the nucleus of an atom. Alpha particles are made of 2 protons and 2 neutrons. An alpha particle is a helium nucleus with no electrons in the orbitals. They're the most massive of the 4 types of radiation that we are studying. This means that they penetrate into the matter the least. They have a positive 2 charge.
Protons and neutrons are the subatomic particles that can be found in the center of a nucleus. Protons have a positive charge, while neutrons have no charge. The strong nuclear force binds the protons together. Otherwise, the positive charges would all repel to blow the nucleus apart.
The electrons may be found orbiting around the nucleus. They orbit in the orbitals and shells which are each a certain distance from the nucleus. The first orbital is the 1s orbital and is in the K shell. 2 electrons may be found in the s orbital, and they orbit around the nucleus in the shape of a sphere. The 1s orbital is the only orbital in the K shell.
Beta particles are electrons. They result from the breakdown of a neutron in the nucleus. A neutron is a proton combined with an electron. When the electron leaves, the proton count for the atom increases, and the atom actually changes to the next element on the periodic table. Atoms are defined based on their numbers of protons.
The next electron to be added to an atom after the 3p orbital is filled moves to the 4s due to electron repulsion. Element 19, potassium, has 1 electron in the 4s orbital. Element 20, calcium, has 2 electrons in the 4s orbital.
Neutron emission is the result of a neutron being emitted from the nucleus of an atom. Neutrons help to stabilize atoms, but when there are many neutrons, the atom actually becomes unstable. The nucleus ejects neutrons until stability is achieved.
Gamma rays are the most dangerous form of radiation because they are pure energy. They are the most penetrating, but they are not made of matter and do not have a charge. Gamma rays are made of energy packets called photons.
Alpha particles, beta particles, and gamma rays are able to ionize atoms. Neutrons do not ionize atoms because they have no charge. For this reason, neutrons are able to penetrate matter deeper than alpha or beta.
The atomic number represents the number of protons for an atom. It sometimes represents the number of electrons. When an atom has a charge, the atomic number does not represent the number of electrons, but the number of protons in the nucleus has not changed.
The atomic mass represents the average of the mass of the abundance of the isotopes for an atom. For instance, there are 3 types of hydrogen: protium, deuterium, and tritium. 99% of all hydrogen atoms are protium. Deuterium and tritium represent less than 1% of the mass each. Therefore, the atomic mass for hydrogen is 1.0078 because the average mass is closer to that of protium due to its abundance.